Kia ora Year 12, here are two more questions from the 2004 Cambridge A-Level paper, the Pure 3 paper. They're both worth 6 marks. So have a read through and try them on your own first, and then I'm going to work through them both slowly. Okay, so the first one is a trig proof, and this is what we've got to prove. So prove that this is the case. So let's just look at it before we start. Now, when I look at this, I have quite a strong preference for starting on the right-hand side and working towards the left-hand side. It'll work out fine if you go the other direction as well, but you can see a double angle screaming out at us from the right-hand side. So let's start there. Remember from level 3 that when we do a proof, we have to make every step of working really clear. So we start by saying, here is the right-hand side. I'm just going to work through this without talking to start with. Now I need to choose which double angle formula I want, and I've got a 1 here, so I want the double angle formula that's going to subtract a 1. Alright, so it's 1 minus 2 sine squared times of sine squared of 2 theta, not of theta. So cleaning that up, we get 1/8. Now I'm going so slowly here, so I don't want you guys skipping lots of steps. Okay, now what do I have? I have a quarter times sine 2 theta times sine 2 theta. So double angle again. You don't have to have exactly these steps, right? You could have done this line as 2 sine squared theta, cos squared theta, cos squared all squared, but you just need to make sure that the reader can see exactly how you've got from one line to the next. Otherwise, you're just going to throw marks away. And what do I have here? Well, I've got 4/4 sine squared theta, cos squared theta. This is probably overkill, actually. You probably could have written just 1 there, which equals sine squared theta, cos squared theta. And then we really need to say on a new line, preferably lined up nicely, but I can't squeeze it in, equals left-hand side as required. Okay, so that's how we do a nice, elegant mathematical proof. That's the first 3 marks of the question. Now we're going to use that result to find a definite integral. So here's my definite integral. Right, so it's a pretty straightforward integration problem. One integrates to give me theta, and then I'm going to have minus 1/4 sine 4 theta. Right, as usual, just check that this differentiates back and gives me the right sign, SIGN, and it does because sine differentiates to give me cosine, and I want to have a minus sign, and I need to multiply by 1/4. Okay, and now I've got my limits of integration of pi on 3 and 0. So what does that equal? Well, I've got 1/8 of pi on 3 minus 1/4 sine 4 pi on 3. Remember, you're asked to give your answer as an exact value, minus, now substituting in 0, 0 minus 1/4 of 0. So the only tricky bit in here is we have to remember what's sine of 4 pi on 3. So we're going to use our special triangles. Where's 4 pi on 3? There's pi. Pi on 3 is down here. 4 pi on 3 is down here. Sine of theta is y over r. So just drawing in my triangle, what have I got? Well, I've got root 3 here and 2 here. So what does that leave me? Well, I've got 1/8 of pi on 3 minus 1/4 times negative root 3 on 2. Remember, all students take calculus or our spicy taco cart. I forget what we ended up using in class, but sine of 4 pi on 3 is going to be negative because of the quadrant it's in. Alright, so one more line just to clean that up. I'm going to try and fit it on the bottom here. So we've got pi on 24 plus root 3 divided by 64. Okay, so that's 6 marks done. Now the next question is a differential equation one, where for once we don't have to bother with separating the variables. Okay, let's take a look at the last one, just to move my stuff around. So, starting with dy by dx, we notice that, what do we have? Y cubed plus 1 over y squared. Now we could start to muck around with this and simplify a bit, but we're not going to bother because we know that we need to have all the y stuff with y. So cross multiplying gives me y squared over y cubed plus 1 dy is equal to dx. So that's equal to 1 dx. And now I can integrate with respect to y and x. So looking at what I've got here, the integral of this side will be 1/3 log of y cubed plus 1. And remember, we don't have a plus c there because it all gets swooshed up together with the x. And over here, the integral will be x plus c. So the next thing we need to do is that we know that 0, 1 is on the curve. So we're going to substitute in to get c. 1/3 times the natural log of 2 is equal to 0 plus c. So c is equal to 1/3 log 2. Right, so now we come back to here and we're going to work all the way through to get y equals something. So we've got 1/3 log of y cubed plus 1 is equal to x plus 1/3 natural log of 2. Reorganising. That's what I have. So all of that equals x. I can't fit my x in there. There we are. Right, now use your log rules. We've got 1/3 times the natural log of y cubed plus 1 over 2 is equal to x. Now, we need to make y the subject, so we're going to put both sides, we're going to exponentiate both sides, is probably the proper word for it, so we're going to do e to the power of both sides. That leaves me with y cubed plus 1 over 2 equals e to the 3x. Y cubed equals 2e to the 3x, take away 1, so y is equal to 2e to the 3x minus 1 to the power of 1/3. So there you go, 6 marks for that. Not too bad. Thanks for watching.